The oil industry has been continuously developing over the last decades. With increased data acquisition and more frequent seismic shooting, it is possible to model the reservoirs before drilling. In the beginning, the focus was on locating hydrocarbons, while in more recent years one has placed a greater emphasis on optimizing the recovery. The recovery of oil in the future will demand better knowledge and more advanced technology than previously. Today, a typical day at work for a reservoir engineer may comprise the construction of a reservoir model from the data available from seismic data, wells, and production history. This work faces several bottlenecks. For example, a major problem with current workflows is that this process is very time-consuming. It may take up to 5 years to produce a satisfactory reservoir model. This is partly due to the work process involving cooperation both across interdisciplinary boundaries and between different geographical locations that may often be located in different time zones. In addition, today's simulations and reservoir models are very inaccurate, sometimes forcing the engineers to make assumptions and interpretations based on fairly insecure grounds. Today's main challenge is that the engineers lack knowledge, which also leads to the reservoir models being imprecise. Our idea is to present a 3D reservoir model using hologram technology. This model enables the user to scale the model to one's purposes, extract relevant information, follow real-time simulations, and cooperate with coworkers situated in different geographical locations. One will be able to do this using voice control, gesture control and haptic technology, and of course a normal keyboard. In addition, these controls may be used to rotate the model and split it so that one can observe its interior. It will be possible to add comments, new information and figures to the model. One can choose whether one wants to make the changes permanent or not, and one has the option to make these additions visible for all users independent of location. Constant update of the model makes it possible to follow any changes in the reservoir. The system should ideally consist of a holographic projector with a microphone and a 3D positioning system placed on it, noticing motion in or near the hologram. Whether or not the projector should be portable, large or small is thought to depend on the user area. The hologram will make it easier and more effective to create a more detailed reservoir model with a better visual imaging. Today's visual reservoir models require a lot of knowledge to be able to understand them. Our hologram would make it so that one will no longer be as dependent on the human eye as before, as it provides us with the information needed. Our idea makes it possible for people from several disciplines to be able to cooperate from different geographical locations, and they will be able to open the same model and perform updates simultaneously. For example, if an unexpected problem occurs, a multidisciplinary team made up of people located in different geographical areas can solve this problem together by using our idea. In order to meet future energy demands, increased offshore exploration and recovery of the available oil and gas is taking place and will continue to do so for the next several decades. In addition, no alternative energy sources have yet been found or invented that can replace the black gold. As long as there is a worldwide demand for oil and its energy, and enough purchasing power is present, the development of technology will continue in the same or an even faster pace. In the future, it will become more difficult to extract the remaining oil and gas reserves, therefore more accurate reservoir models are needed. Our idea, with its technology, will help to obtain this. It will also simplify the interpretation of these models by visualizing the information in an intuitive way. Our goal is to provide the user with a model that gives a great visual of the reservoir and in addition offers direct access to relevant information such as reservoir properties, the amount of hydrocarbons already produced, etc. We expect the required technology to exist by 2030.